Good morning. Thank you for getting started on this video. So these are examples that go with the video that you watched Friday. So for the first example, and this is additional example, so it's not the one that's in your book, but it's similar to it. Example 1, let A be the set. These funny brackets just show this set of numbers, 2, 3, 4, 5. And let B be the set 3, -2, -1, 0, 1. Is the following set of ordered pairs representing a function from set A to set B? So from set A to set B, we should, in each of these ordered pairs, the first number should come from set A and the second number should come from set B, the way that's written. So here is the first set of ordered pairs. There's 4 points there. And we just want to see, if you just look real quickly at all these first values, they are all from set A. And the second values are all numbers that are from set B. So all we want to see is, do they represent a function? So there's lots of different ways, according to the video Friday, that we could figure this out. Number one, if I just consider graphing these, and if I think about what they look like on a graph, and if I just roughly just sketch these real quickly, 2, -2, somewhere here, 3 zeros, like right here, 4, 1 would be about here, and 5, -1 would be like here. Those are going to pass the vertical line test. So if they pass the vertical line test, then yes, this represents a function. The other thing you would do is you would just make sure that all these x's are different. That way, all these x's are different, and so you're not going to have 2 points that line up on each other because they have the same x but different y's. So yes, A part is a function. And when you look at B part down here with this set of ordered pairs, you could just make sure all those x's are different. And when you look at them, you see, I've got 2 points that begin with the x-coordinate 2. So when you go to graph those, let's say we just graph those 2 points. This point right here would be at 2, 0. Oops. And this point right here would be at 2, -1. They line up on top of each other. They would fail the vertical line test. So this is not a function. Okay, example 2 asks us to determine whether the equation represents y as a function of x. That sounds pretty confusing. They just want to know, though, is this a function? If you graphed this, would it pass the vertical line test? So the easiest way to try to graph it is to solve it for y. So we could subtract x squared from both sides, and we would get y squared equals 8 minus x squared. And then we could take the square root of both sides. And when we take the square root, we get plus or minus the square root, 8 minus x squared. That means y is giving us 2 answers. Y is the positive root, 8 minus x squared, and y is also equal to the negative root of 8 minus x squared. So y is equal to 2 different values. So this is not a function. If you put in this one value of x, like if you put in x equal to 1, you're going to get 2 different values for y. This one would give you y equals, if x equals 1, you'd get y equals positive square root of 7. And on this one, if x equals 1, you'd get negative square root of 7. So that would give you the points 1 positive square root of 7 and 1 negative square root of 7. So you're going to get 2 answers for that one x value. So it's not a function. This is actually a circle. I don't know if you remember that or not. A circle formula is x minus h squared plus y minus k squared equals r squared. This is a circle centered at 0, 0, because it's really like x minus nothing squared, because it's just x squared. So it's x squared plus y squared equals 8. So its center is 0, 0, and it has a radius of square root of 8. Just extra. You don't need to know that, but you might see it on an SAT test. Let's do B part for this. A part was not in your book. B part is in your book. So on this one, if we want to see if this is a function or not. Oh, actually I don't want to do B part. I want to do A part. Is y a function of x? Well, let's solve it for y to see. So let's try to get the y by itself. Let's subtract x squared from both sides. Oh, this y is equal to that. That's one value. Y is equal to that. If you put in x equal to 1, then you're going to get y equals 1 minus 1. You'll get 0. That gives you the ordered pair 1, 0. Just one singular ordered pair when x is equal to 1. So it's not going to fail the vertical line test, and it is a function. Okay, example 3 moves on to something that I think is more fun. We're going to let f of x equal 10 minus 3x squared and find A, f of 2, B, f of negative 4, and C, f of x minus 1. So this is our function rule, and this is the x value that we're going to substitute into this rule to figure out what f of x equals. So if x is 2, everywhere there's an x here, we're going to put a 2. So f of 2 is equal to 10 minus 3 times 2 squared. These are the same, except all the x's got replaced with 2's. Then you just work it out. That is 10 minus 3 times 4. That is 10 minus 12, which is negative 2. So f of 2 equals negative 2. Now B part is going to work really similarly. You're going to go back to your function rule, but everywhere there is an x, you're going to put negative 4, because that's the x value. So f of negative 4 is 10 minus 3 times negative 4 squared, which is 10 minus 3. Order of operations says we have to do exponents first. And you're squaring the negative and the 4, so it's a positive 16. So that's 10 minus 48, which is negative 38. So f of negative 4 equals negative 38. This last one, that should have been a C there. This last one's a little more complicated because it's not just a number that we're plugging in, it's a variable expression. But everywhere there's x, we're putting all of that. So f of x minus 1 is equal to 10 minus 3, parenthesis, x minus 1 squared. See, it's still this, and this are the only things that are changing, and they're all based on these x values. That's just what I do. So to work this out, we're going to have to square this binomial first. So I'm going to, over here to this side, I'm going to do x minus 1 and x minus 1. Foiling. First, outer, inner, last. I'd like to show you the shortcut when we're together in class, but I don't want to do it by the iPad. So there's that squared. Now order of operations says I have to distribute this negative 3 to each of those values. So it's negative 3x squared plus 6x minus 3 So now we have 10 minus 3x squared plus 6x minus 3. And I'm just going to write it in standard form with the x squared term first, next the linear term, and last the constant term. That's definitely a little more complicated, but that is where we're stopping for today.